All right, guys. So here we go. We have nice, nice. I suppose I use that term nice lightly. A nice sine curve that we want to graph. Let's go ahead and kind of go through the steps here of identifying our transformations. Luckily for us, kind of the one few things that maybe are lucky here is that B is already factored out, right? We can already tell that right here that we have a B value that's factored out. So we're good to go on that one. Check. Amplitude in this case, so our amplitude is going to be based on this A value here. So that's 4/5. That'll be fun to graph that. Our period is going to use this B value to calculate that. So we do 2 pi divided by B. And when we simplify that, we actually get 6. So this is actually a nice whole number period, which should make the scaling along the x-axis a little bit easier, things like that. Then we have our phase shift. So phase shift is +2 here, remember, which actually means we're going to the left 2, which means that we will start at x equals -2. So on our x-axis, we're going to start at -2. Vertical shift, another fractional value here, we're going up 1/5. So that's where our midline value will be. And reflection. In this case, there is no reflection. Just to keep this in mind, we'll sketch out the 5 friend points that we'll be using. So this is a sine curve. We're going to be graphing a standard, not reflected sine curve. Something like this. All right, so going through our graphing steps, the first part that we have is identifying our midline and then identifying our minimum and maximums. And these kind of go together and they all help us scale along the x-axis. So our midline is at 1/5. So I'll just make this 1/5 here. And then we're going to go up 4/5 from that. So 1, 2, 3, 4. So that's 2/5, 3/5, 4/5, 5/5. It'll actually be up at 1. And then we're going to go down 4/5 as well. So 1, 2, 3, 4. So that's going to be -1, 2, 3, -3/5, where our minimum value would be. All right. So you can draw these guiding lines if you would like. You don't have to, but I like them there. So I'm going to draw my midline. I'm going to draw my maximum value. It's up there at 1. And my minimum value down here at -3/5. And I'm going to adjust that one up just a hair because I want to. All right, so that's steps 1 and 2. We've established where our midline is, established our upper bound and lower bound, and we even have a nice scaling to work with. Now, what we need to do next is steps 3 through 5, which begin with finding our starting value, finding our ending value, and making sure everything is split up nicely. One thing I do like to do is to get an idea of what scaling to use. I kind of compare my starting value. So we are starting at x equals -2, so that's shifting over to the left, and compare that to what happens when I divide my period by 4. Because remember, we need to divide our period into these 4 sections. You can see here on the bottom left, I'm doing it. You always want to divide it into these 4 sections so that you can graph your sine curve, or cosine curve. So I want to take my period, 6, divide it by 4, see what sort of units I may need to be working with. So that actually gives us 1.5. Because we're dealing with whole numbers and not fractions of pi, I don't love kind of counting my x-axis by 1.5. And the other issue is if I do that, when I go into the negative direction, I'm going to kind of skip over my starting value. So just to simplify things here, I'm just going to count by 1/2 units. Well, I'm going to start by counting by ones, and then I'll break it down further into 1/2 increments. So I'm going to go 1, 2, 3, 4, 5, and then go negatives. -1, -2, -3. And I kind of already know where things are going to go. I probably should have done this first. So we know we're starting at -2, so I didn't need to go any farther than this place as our starting value. And that's step 3. Identify where we're starting. Let's kind of make that a place. So we're starting right there. And then step 4 is where are we ending? So we're ending from our starting value, we end a full period away. So I'm going to add my period to that. That tells me I'm going to be ending at 4. So my cycle is going to go from -2 to 4. All right, that's pretty straightforward, I think, how we got that. Afterwards, the next step, the last step here, is to divide this cycle into 4 even increments. And so to do that, we need to maybe break down our scaling a little bit. So what I'm going to do is I'm going to put some increments in the middle here. So this would be 1/2, 1.5, 2.5, 3.5, -1/2, and -1.5. That just gives me some smaller increments to kind of work with this a little bit better. Again, the reason I want halves is because of this scaling. I know that to break up my full period in 4s, I need to do it in 1.5 increments, so 1.5 units. Again, because these are nice whole numbers, this is actually not too difficult. I know each 1.5 increment is going to be 1/4 of my cycle. So if I go 1.5, this is going to be the 1/4 point, and then 1.5, this is going to be my middle, and then 1.5, this is going to be my 3/4, and then 1.5, again, there's my end. So I have split this up into nice 4 even increments, right? 1, 2, 3, 4. We can hopefully see them. I'm gonna show it here. I'm gonna erase all this stuff because it's just extra, but nice 4 even increments. Let's go ahead and undo all that. Okay. There are other ways I could have done this. I could have found my middle here pretty easily by averaging my starting point and my ending point to find that my middle is 1. And then I could find these quarters by kind of averaging these as well. So averaging -2 and 1, I could find right here -1/2. And averaging 1 and 4, I could find 2.5. A lot of different ways to come up with these, but I kind of used knowing that my period divided by 4 is exactly 1.5 increments to do this. Again, multiple ways to go about it. Now that's step 5. We split our period up into 4 even increments. So now we just need to actually graph it. Cool. Some people like to do the guiding lines again vertically. I'll do it for this one, but I probably won't do it much in the future. So we're starting here. We're ending here. I'm going to shift that one over a little bit. Ending right there. So our whole graph is going to take place in this section right here. Right? This is our upper bound, our lower bound, our midline. This is where our cycle is going to start. This is where our cycle is going to end. The graph continues forever on both sides of this, but this is the one cycle that we are graphing. Okay, let's go ahead and plot the points now. What color have I not used? Let's use a dark blue. So sine has 3 points that are on the midline. So at the beginning, at the middle, and at the end, sine should be on the midline. And then at the 1/4 point, it should be at its maximum. So that's right here. It should be at its maximum, which is up to +1. And at the 3/4 point, which is right here at 2.5, we should be down at the minimum. And those are our 5 friends for this graph. I remember not reflecting it, so I did that right. And I graph it as best I can. And not too bad, I guess. So there we go. That is our nice sine curve, or at least one cycle of it, with all of those different transformations that we went over. This was kind of tricky. These units of the period and the starting point weren't exactly perfectly compatible, but since we were dealing with kind of whole numbers and easy decimals like 0.5, it wasn't too difficult to make them work. Let's go ahead and move forward. So I'm going to clear this off, and the next one's going to be kind of tricky. So let's take our time on it. Okay, so we have y equals -4 cosine 2x minus pi over 3 plus 4. All right. Starting off, we do need to factor out b. So b is a 2, so let's factor that out. That's going to leave us with x minus, and then divide this by 2, we get pi over 6. So that gives us our proper phase shift, which is not a great one. I don't think that's going to be very compatible with our period, but that comes later. Okay, let's look at the amplitude. So the amplitude is absolute value of a here. So our amplitude is 4. Our period is based on the b value. So it's 2 pi divided by b, which is 2. Get rid of those. We're gonna have a period of pi. That's not too bad. That's kind of standard. That's half our normal period. Phase shift is pi over 6 to the right. Remember, minus is to the right, so pi over 6 to the right. And our vertical shift, we are moving up 4, plus 4. And lastly, this is a reflected graph. There is a negative here, so yes, we are reflecting cosine. Let's go ahead and show that real quick. So reflected cosine graph is going to look something like this. Starts at minimum, ends at minimum, middle it's at maximum. And in between those, it's at its midline. So reflected cosine graph, make sure when we plot our points, that's what we're doing. That comes at the end of that. Now what we need to do is steps 1 and 2, which are find where the midline is, find where the minimum and maximum are, and set that up on our graph. So our midline is at 4. Our amplitude is 4. So we're going to be going 4 above that to 8 at a maximum, and 4 below that to 0 at a minimum. So that's actually pretty nice. 4 is our midline, 8 is our maximum, and 0 is our midline. I'm not going to actually label that. I'm going to go ahead and erase that. Did I say midline? 0 is our minimum. Again, you can put your guiding lines on there if you prefer to do that. I'm going to go ahead and do it. I like it. So there's our midline. Here is our maximum, 8, and here is our minimum at 0, or the x-axis. You don't have to draw that one since it's already on there. In fact, I'm going to get rid of it just so I remember that is actually my x-axis. Okay, next, that's step 1 and 2. So we found our midline, found our maximum, and our minimum values, our upper bound and lower bound. Now we need to start dealing with this period and phase shift and x-axis stuff. So first of all, where are we starting? We're going to be starting pi over 6 to the right. So remember, I usually start at 0, but we're shifting. So we're shifting to the right, pi over 6. Okay, I'm going to make a preliminary marking for that. I don't know if I'm going to need to move that around or not, but let's just kind of put it there. And that's where we start. We're going to end 1 period to the right of that. So we take our starting point and we add our period, pi. That's our period. Pi is really 6 pi over 6 to get a common denominator. Add those together, we are going to end our cycle at 7 pi over 6. Okay, so I need to have an ending here at 7 pi over 6. I'm definitely going to need to edit this a little bit, but just thinking it out loud here and kind of making some plans. So that's kind of part of step 3 and step 4, where I've established where I'm starting, where I'm ending. But my scaling isn't really decided here. Usually what we want to do, unless it doesn't work great for us, is take our period and divide by 4. That's pi divided by 4, pi over 4. So that would be a decent scaling for us to use just based on the period, because that automatically cuts our period up into 4 increments for us, and we're kind of good to go. Unfortunately, pi over 4, pi over 6, those are not very compatible. They are not really multiples of each other. And so to really make this graph work nicely for us, we're going to have to actually find a common denominator for these. And a common denominator between 6 and 4 is actually 12. So this tells me that kind of my best unit for my x-axis is to do pi over 12. Or if we think about it as 1/12 of pi. 12ths are not ideal, but we can make it happen. Pi over 6 is really, what would that be in 12ths? That would be 2 pi over 12. right? Just multiplying this by 2. And then 7 pi over 6 is really, what is that? That is 14 pi over 12. So I'm just kind of doing this so that I can make sure I need to count this. If I'm going to count my x-axis by pi over 12 increments, I need to make sure I'm including two increments of it and 14 increments of it. So I need to make sure I have 14 of these. I'm going to erase some markings here because, again, this was sort of preliminary. All right, so let's go through it. Pi over 12, pi over 6, or 2 pi over 12. Let's count it in pi over 12. 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12. I need to get up to 14. This is not working great. I need to go smaller. Sorry. Started again. Need to go a little smaller. I needed to get all up to 14, and that wasn't going to work. Okay. 1 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s, 7 12s, 8 12s, 9 12s, 10 12s, 11 12s, 12 12s, 13 12s, 14 12s. Okay, so this is 14. That's the starting, and that 2 is the beginning. Okay. So that gives me some stuff to work with. Let's select this and move it over if I can. All right, so that goes right there. Now let's do the same thing here. Let's just move this thing over. Ooh, let's do that again. Move right there. All right. Whew, that was not ideal. Again, finding this incrementing and executing it can be a challenge. So, but the benefit is that we have a nice, evenly incremented graph, and we should easily be able to find the beginning, the middle, and all the ending points. We know we're counting by pi over 12 every single even increment. So that's what is good about this. Now we need to find the middle of this. So we could kind of do it two different ways. We could count this scaling, kind of find the middle there. We could average these two coordinates and find the middle there. Totally doesn't matter which one. For me, I'm just going to count it. That seems easiest. So this is 1, 2. Let me do that a different way. Let's go. This is 1, 2, 3, 4, 5, 6. I think that's going to be in the middle. 1, 2, 3, 4, 5, 6. Yeah, so that was the middle. 6 right there. Okay, what's the coordinates of that? That is my middle, but what are the actual coordinates there? Let's count it out. So this is 1 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s, 7 12s. This is 8 12ths, which reduces 8 12ths. Everybody reduces to 2/3, so 2 pi over 3. That's the middle. Okay, so I've got beginning, middle, end, and now I need my quarter points. Okay, so we already said this was 6 increments here, right? That's what we did. So halfway there should be 3. 1, 2, 3. This should be our quarter point. And 1, 2, 3. This should be our 3/4 point. Let's erase some stuff. Again, 3 and 3. Yep, that worked out. Now let's actually write out what are the coordinates. I would like to know these exact coordinates on your graphs, so make sure to include them. Let's see what we end up with. So this is 1, 2, 3, 4, 5 12ths. That does not reduce, so 5 pi over 12. And 5, so that's 6, 7, 8, 9, 10, 11. This is 11 pi over 12. Whew, okay. We got it. We have everything we need. Scaling is nice. I say that hesitantly, but it's nice. I got all my places marked. I should just be able to graph my cosine curve at this point. So let's go ahead and do it. We are starting at our minimum value, which remember is the x-axis here, because we're doing a reflected cosine curve. Start at the minimum, end at the minimum. In the middle, we're at the maximum, so that's right there at 2 pi over 3. That's the middle. We're at the midline here, which is 5 pi over 12, midline, and midline here at the 3/4 point as well. So that's our reflected cosine curve. Remember, it is reflected. That's a place that you could just make a small mistake and kind of throw all your hard work away. And now we want to sketch the curve. Okay. Not the greatest, but worked out okay. So there we go. That's our nice cycle of cosine that we graphed there. And yeah, I'm happy with it. I'm gonna go and end this because I think it's already getting long, and I'm gonna stop the recording and go ahead and do a part 4 for going the other direction. Or sorry, part 3. We're gonna look at some graphs and try to write the equations of those. Anyway, I'll see you in part 3.